Hello, family. Welcome to the castle of Maths Fanatics. So in front of us here, we have a question on statistics taken from KwaZulu-Natal Paper 2 Preliminary Examination 2019. Okay, without any further ado, let's get straight to the point. So here they say the following information represent the amount of maize exported to other countries over 11 years in 1,000 tons. Then they give us our data here, which is already what? Arranged in ascending order. We always need to make sure that our data is arranged from smallest to biggest. Okay. Awesome. So now let's check. Calculate the mean amount of maize exported over the 11 years. Okay. So let's do 1.1. So to calculate the mean, right? We use a calculator. We go to mode, and then you go to statistics, which is 3. Then we're working with variance, which is 1. Then you're gonna input your data set. 39 equals to 42 equals to 48 equals to 54 equals to 62 equals to 68 equals to 78 equals to another 78. Okay, and then we have 82 equals to 91 equals to 93 equals to. After you have input all, you press AC, and then you go to shift, and then statistics, which is 1, you see. And then we're working with 4 on a variance. So 4. Then let's do this quickly. So if you check number 2, it's your mean. This is the mean. And then number 3, it's your standard deviation. Perfect. So this is standard. Yes. Okay. Let's get the values. So I'm gonna quickly get the mean, which is on 2. So you press 2, then you press equal sign, right? Then we can easily see that our mean is what? It's 66.82. Remember, we always round off to 2 decimal places. So here I have 81, so it's gonna just add 1 more because it's above 4. Do we get it? Perfect. And then to get the standard deviation, you press AC, then you do shift again, statistics 4, 3. That's your standard deviation, okay, which is 18.30. I mean 18.30. Do we get it? So that's our mean. This is our standard deviation. This is our mean. So if I check here, I already answered 1.2. So I always just get both the mean and the standard deviation because they always, most often than not, they always ask both. So this is done, that's done. Okay, let's go to 1.3 now. Okay, I just want the calculator to disappear a little bit sharp. So now here on 1.3, they say we have to calculate the number of years that are within 1 standard deviation of the mean. Okay. So this is the most important interval that you should know. So it's X, which is your mean. On this, we call this a lower boundary. So we minus in, minus 1 multiplied by standard deviation. Why am I multiplying by 1? They said within 1 standard deviation. If they said within 2 standard deviation, I'll put 2 there and so on, okay? Then X, then this we call it the upper boundary. So we're gonna add 1 standard deviation of the mean, okay? Then now we can substitute our values. So my mean is what? Is 66.82 minus 1 multiplied by 18.30. Then my mean is 66.82 plus 1 standard deviation, right? Awesome. So now let's get our calculator and see what does this give us. Okay, so AC, now let's see. So we have 66.82 minus 1 in bracket 18.30. This gives us 40 watts, 48.52. Then we have to add it now for the other boundary. So I'll just go here and put plus, right? Then this gives me 85.12. Okay, this is the interval of the data set that lies within 1 standard deviation of the mean, right? So now since we have the interval, we can easily see the ones that falls what within. So within is like inside between these two numbers here, right? Sometimes they'll say outside. If they say outside, you look for the ones that do not fall within this interval. Does make sense? Sure. So this is out, this is out, this is out. Okay, let's come from this side. This is out, that's out. All right, so how many falls within is 1, 2, 3, 4, 5, 6. Therefore you're gonna say what? Therefore 6, yes, right, falls within. Then you get your 2 marks then. Usually they put it 3, but here they were stingy. But I hope it makes sense. So we can go to 1.4, right? Okay, so on 1.4, they want us to do, okay, let me just write our answers here. Maybe we might need them. So the mean is 66.82. This is 18.30. This was 6 years. Ne? Sharp. Okay, let's go here. Draw a box and whisker to represent the data. Okay, to draw a box and whisker, right, we need the 5 number summary. Ne? The 5 number summary, which is mean value, which is 39 in this case. I need the maximum value, which is 93. I need the quartiles. Ne? I need the lower quartile, the median, and I also need the upper quartile. Ne? Okay, sharp. Remember, lower quartile is the median of the 50% lower part this side, ne? And then Q3 this side, and then Q2 is exactly somewhere in the middle. Ne? So this is just the 25% of the data. Ne? 1 plus. Okay, actually, I'm gonna do this. I'm gonna calculate. Let me get my eraser. I'm gonna calculate Q1 first, and then we'll calculate the rest. Term, ne? This formula just gives you the position. Okay, so now N is the total amount of items you have. Ne? So in this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they said 11 years there. Do you see it? So N equals to 11 in this case. So we need 25%. I'm going to substitute my 11 there, plus 1. 10. Ne? Let's see what is this. Okay. Get my mouse and then let's do this now. So we need 25% of 11 plus 1, right? This gives us 3. So it means our Q1 is in the third term. Okay. So which is equals to 48. Do you see? So we're gonna say 48. Done. Now we're gonna do the same. Q2 is 50% of the data, ne? Of 11 plus 1 10. Okay, so I'm gonna replace this part by 15 at the percentage. I'm gonna replace it by 50. So 50. Okay, it gives me 6. So it says Q2 is in the 6th term. So term number 6 is 1, 2, 3, 4, 5, 6. So this is my Q2, né? So which is 68. Sharp. And then Q3, it's 75%. 75%. 1 plus 10. It should be, let's see here. It should be 75. Okay, so they say it's on the 9th term, né? 9th term. Okay, perfect. So the 9th term is what? So 6, 7, 8, 9. So it's 82, né? 82. So I have my 5 number summary there. But before I go to sketch a box and whisker, right, I want to show you some other strategies of doing this, né? Sharp. So the normal way of doing it without the formulas, let me show you how we go about it, né? Sharp. So we do the, let me get a highlighter. Let's get a highlighter. Okay. So firstly, you're going to look for the normal median, the way you learned how to do it in grade 10, which is the middle term, right? So you have 11 terms. Obviously, the center will be this part here. Yeah. So, okay, let's do this. Okay. Let's do this. Okay. So this one is my main center, right? Perfect. After you get it, it's a Q2, né? And then you cancel it. You take it out, basically, right? And then your Q1 will be the median of this part. So I have 1, 2, 3, 4, 5. So the middle one is term number 3. You see? So this is Q1. Then Q3 will be here. Do you see it? Because don't include the median like the Q2, né? When you do the Q1 and the Q3. So Q1 is the median of this side, and then Q3 is the median of that side. Okay, but my advice is know both ways, right? Because these formulas are important as well, especially when we do the Ogive curve or the cumulative frequency curve. You'll really need to know these formulas, okay? Perfect. So now I can go on and draw my box and whisker. Let me just list my things here. So mean 39, max 93, Q1 48, Q2 68, Q3 82. Awesome. So we're going to now try to sketch our Ogive curve. Okay. I mean let's check. We're going to try to sketch our box and whisker. Okay. Check that. Awesome. So I'm seeing, so before I draw a box and whisker, I need to determine the scale that I'm going to use, right? I'm seeing that the smallest value is 39 and the biggest is 93. So going up in tens would be making more sense to me, right? So obviously I'll start at 30 because the biggest is 39. So my 30 will be here. My 40, 50, 60, 70, 80, 90, 100, right? Then we can start. You always start with mean and max, now with dots. So 40 is here, so 39 should be, okay, let's do it here. So 39 should be somewhere, no. Sorry about that, ladies and gentlemen. Let's do this. Okay. So my 39 should be very closer to 40, right there. Then 93 must be closer to was 90, eh? So I can put it somewhere here. Awesome. And then now let's do Q1. So this is 40, this is 50. So 58 maybe can be somewhere here, right? 48 can be somewhere there. Sharp. Then we need 68 now for Q2. And then I advise you to just show the values here. This is 39. That one was 93. Ne? Sharp. Now let's get to Q2, which is 68. So where's 68? So here we're in 50. 60, 68 can be somewhere here. Sharp. And then we need Q3, which is 82. So 70, 80, 82 can be somewhere there. And then you join them, ne? You join them. Join them. You join. And that's your Boskin-Whisker diagram. Right. That's your Boskin-Whisker. Okay. So we can go back up now. That's our Boskin-Whisker. Okay. So they want me to comment on the skewness. Ne? To comment on the skewness, it's easy. Ne? You check the longest distance. When I check here, I can see that this line from here to there, it's longer than from here to there. So it's always from Q2 to Q1 and from Q2 to from Q2 to mean and Q2 to max. From Q2 to mean and then Q2 to max. The longest one is on the left, so it's skewed to the left. Ne? Skewed to the left. Or you can say negatively skewed. Ne? Negatively skewed. Okay, the other way to do it is this. Ne? Skewness, you always get it by mean minus median. Not vice versa. It's always mean minus median. If you get a positive number, it's positively skewed. If you get a negative number, it's negatively skewed. Okay, now let's check here. Okay. My mean was? What was my mean? It was 68 point something. Let's check. What's my mean? 66 point something, I think. Okay. Let me check it quickly here. So we're gonna have 4, 2. It was what? It was 66. It was 66.82 ne? Minus 68. You can see that you're gonna get the negative answer here, right? If you press it on a calculator. So you're gonna say negatively skewed. Ne? Okay, now let's finish up quickly. On 1.6, they say there was an error in the data. The mean amount of maize exported over the 11 years should increase. Okay, so the mean must increase by 1.25 thousands of tons. What impact will this error have on the yearly data provided in the table above? So obviously, if the average is increasing, this data must what? Must increase, right? The values of the data must increase, right? Good. Now let's check this one. On the interquartile range of the given data. Okay. So now, guys, as I said here, the total value will increase, right? When we add them together, this data set here. But for example, this one is an open-ended, right? It's open to a lot of arguments. For example, okay, let me circle my quartiles. It was this one and that one, right? Remember, interquartile range is Q3 minus Q1. So I'm interested in those two. Sharp. So for example, this cannot, they can maybe add there, then not add here, add everywhere and not add there. So it can remain the same. Right? Or they can do this. They can increase here and leave that one the way it is. Does it make sense? So it can, which means the IQR can increase or decrease, basically, depending on how we are adding, right? Perfect. So you can say it will change or remain the same. Change meaning increase or decrease. Does make sense? Yeah, so this one was an open-ended question. So ladies and gentlemen, if you found this helpful, please kindly hit the subscription button and share with other maths fanatics. And also feel free to leave a comment on the comment section. Thank you. We will meet again soon, ladies and gentlemen.